Welcome back to Advent of Code 2022. John Eisen here. If you guys like these videos, hit like and subscribe. I'm trying to start a channel. I'll be doing leak code videos after Advent's over. But now we're on day 7, so let's get started. No space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally you even hear much louder sounds in the distance. How big did the animals get out here anyway? The device the elves give you has problems with more than just its communication system. You try to run a system update, and it says no space left on device. I love this pretty please with sugar on top. I feel like I do that all the time. Perhaps you can delete some files to make some space. You browse around the file system to assess the situation. Save the resulting terminal output or puzzle input. Oh, nice. We have to parse terminal input. For example, we have cd, change directory, ls, list. We get dir a, so that's a is a directory. This must be a size of a file, another directory. You can cd to another directory, and ls again, and we get sizes and file names. Nice. The file system consists of a tree of files. Each directory, other directories, the outermost directory is called /. You navigate around the file system, moving in and out of directories, listing the contents of directories you're currently in with terminal output lines that begin with the $sign are commands that are executed, very much like some modern computers. Yes, $sign is the input symbol for when you root in Bash, or sometimes just always in Bash. It depends. cd means change directory. Yep, that moves in. cd ... moves out. cd / switches to the root directory. ls means list. Prints out all the files. 1, 2, 3 ABC means size. Yep, we were correct. And dir means that there's a directory inside our current directory. Given the command, you determine the file system looks like this. Nice. Here there are 4 directories, and since the disk is full, your first step should be to find the directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of the directory is the sum of the sizes of the file it contains, directly or indirectly. Directories themselves do not count as having any intrinsic size. So this means that like E has size 584, but A has size of E plus these 3 sizes. So but A does not contain b.text. To begin, find all the directories with the total size at most 100,000. Then calculate the sum of their total sizes. In the example above, these directories are A and E, and their sum of their size is 95,000. As in the example, this process can count files more than once, right? Because A contains E, so this 584 is in this 94,000. Find all the directories with the total size of at most 10,000. What is the sum of their total size? So, okay, so how are we going to do this? First, let's just come up with a plan, right? So we have to parse this input, and from this input, we have to get a directory tree, probably a structure that looks like this, and then we have to sum directory sizes. Now, we could take a more direct approach. There's 2 ways to do this. We could map the input to this like tree structure so that we have a full mapping of all directory sizes, and then whatever part 2 is will probably be pretty easy. Or we can go directly at part 1 and say, okay, like when we're in this we're in cd / and then we're in ls, we can just be like, okay, / has some size plus the future size of A and the future size of D, and then we then we can use maybe recursive programming based on the input to go find the size of A. I think that is maybe only a tiny bit faster, probably harder to think of, and won't help us in part 2. So my goal is going to be to parse this input into a tree structure. So let's do that. I guess we should assume that the command input will list everything, right? If it doesn't list everything, then like, what are we doing here? So let's go example here. And while we're at it, we're gonna get the puzzle input. It's a little bit longer. Day 7/day 7. Okay. All right. Let's get started with parsing the input. This is super fun. I'm excited. All right. So our input is going to be just a list of lines. Okay. So we don't have to do anything to parse input here from our template. And then we're going to map input to trees. So def input to tree. And we're gonna, well, we'll call it execute because we're execute. Or yeah, whatever. It doesn't matter. Input, and we're gonna output tree. Directory store tree. We're just gonna call it tree. Data class tree. And each, or call it a directory, and we're going to have files is a list of tuple of int and name. So this would be file name and size. And deers is a list of directory. And I guess a directory has a name. Nice. Okay. So yeah, there we go. Cool. Just no colon on data class. Cool. All right. So we're outputting a tree. Nice. All right. So we're executing these instructions. So we're going to assume the first if input 0 does not equal $CD/, then we're going to raise an exception expected CD/first. All right, so we're just going to assume it's CD/, so that and input 1 should be the ls. Well, actually, yeah. CD/and ls first. All right, so we expect to go to root and then change to and list the directory. So, but that's true in our input and our example, so we can just assume that. So let's start with how are we gonna do this? So current directory is /. We're going to say, actually, cur is going to be a directory equals directory name /. Okay, so when we initialize our directory, we're gonna start with like not having anything in it and look, and our location is and we're gonna have top level directory. So we're starting at the top. Actually, we'll leave this as, okay. All right, and then we're gonna actually input is .lines here. All right, so I'm thinking, sorry, I'm not talking too much. I'm thinking a lot about how to do this. And what I wanna do is I wanna walk down the list of inputs, grabbing the next. We basically want to split by which lines have a $, and we want to do something every time we find a $sign line. So I'm going to have a rest. So this means the rest of the lines equals input.lines. And then we're going to update that until it's empty. So while len of rest is greater than 0, so while we still have lines to interpret, assert rest 0, 0 equals $. So this means that our next line should always start with the $. That is our, and we are left to figure out how to do that later, but that's what we expect. So command equals rest 0. If command starts with $, rest 0, we'll do dot split on $1, so this gets us the actual command. So if the command starts with cd, then we're going to dir. So dir equals command dot split on space 1. Okay, so now we have the dir stands for the directory to change to. So if dir equals slash, then cur should equal top. So this is what we're doing in this particular case. We are going to switch our current directory to the top directory. All right, so this handles the first line, and then we rest equals rest 1:, and we continue. All right, what else? Else we can switch up a directory. If dir equals ... If we go up a directory, then we need to keep, we probably need to keep a reference to parent here, directory. And this is optional. Why is it optional? Because actually, we're going to make all these optional and have them start as none. That just makes things easier. The reason it's optional is because the top directory doesn't have a parent. Every other directory should. And so since all those have initializers, we can just do this. All right, so else if our dir is ... then we need to do cur equals cur.parent. And we should assert cur.parent is not none. So if we get here, we can exit out. And then we do rest equals rest 1 and continue. All right, else. So this is our final case, and this is if we're switching down a directory. Now we have to assume that this directory exists. So then cur, so dir equals cur.folders f for matching folder is f for f in folders if f dot name equals the dir. So we're going to find our matching folder and assert matching folder. This needs to equal 1, right? So we're just looking through the set of folders to get one that is, yeah, that is good. And then that matches the name that we're looking for. And then let's scroll up here. And then we're just going to say cur equals matching folder 1 rest equals rest 1 continue. And now we notice that every single condition repeats these 2 lines. So I'm going to bump these out of the if block and do this. All right, so now we've handled the CDs. Now we just need to handle ls. Else. Elif command equals ls. All right. So now we just need to handle the list. So what we want to do is pick every line until one starts with a $. And so let's just do output equals, this is a take function, right? Iter tools, take. Drop while or take while. We want take while. Take while. Here it is. All right. So make an iterator that returns elements from the iterable as long as the predicate is true. So we can import this function from iter tools import take while, and we can say the output is list. So it's going to return an iterable we want to list. So it doesn't matter if it's list. It doesn't matter actually. All right, so take while. The predicate here is lambda line 0 does not equal $. So we're going to take each line that doesn't start with a $, until it does. We do need a list because we have to read the length as well. Sorry, I'm thinking ahead. All right, and then our iterable here is the rest of the lines, starting with the first, because the first is the ls command. All right, and then let's see, what do we want to do? And then, all right, so then output should be a list of each line. It should be these lines, right? So the first thing I want to do is I want to take care of that rest. So we want to do rest equals rest. And we don't want to take the first because that contains the ls, but then we want to take off all of the outputs as well. So we want to do 1 plus len of output, and we want to do : All right, so that should get rid of all these lines so that the next loop and doesn't matter. And also, I guess we don't need continue because we're not going to do anything after this, so we're all good. And actually, I'm going to move this rest equals rest 1 by up here, and that way we don't have to do this. So this is cleaner and this is cleaner. I like clean code. Cool. All right, so nice. So now we have our output, so we just need to parse that output. So for line in output, we want to fill up our directory. So we're going to have cur dot, so we're filling in the current folder. So for current directory, it's cur.folders equals this, and cur.files equals this. Just initializing to empty arrays. And we're going to do if line dot starts with, actually we're going to do type or size, call it dir or size, and name equals line dot split on this. So then we're either going to get dir or we're going to get a size, and we're going to get the name here. So if dir or size is dir, then we want to do cur.folders plus equals a directory, and we want to initialize this directory with directory of name. Nice. And now that's an empty directory that we'll fill up later. Else, oh, and directory of name parent equals cur. That's very important. Otherwise, we won't be able to navigate back up. And then we do cur, and then if it's not that, then we do cur.files plus equals a tuple of the int of dir or size and name. So nice. Cool. All right. So that, and then after this else, we're going to go through the while and we're going to return top. And now we have a directory structure. We need to change this return type directory. Since this is so complicated, the first thing I like to do is print our we'll do tree equals execute input and print tree before we go solving the problem. And iTerm wants to update. We're not going to do that right now. CD day 7 or Python day 7 example. Directory is not defined. How do you Python self-referential type annotations? How do you self-reference, forward reference type annotations. In Python, type hints. T equals type var t. Oh, you just put them in quotes. Okay. All right. So we're gonna quote directory and quote directory. Does that work? The tuple cannot be instantiated. Use tuple instead. Yes. This is again not. Must be square braces. I keep doing that. Local variable rest is referenced before assignment. Yes. It's not. Actually, that means that we don't have to fill this in here because you can have that. But our rest input lines, needs to be equals. Just a little typo there. I thought it was a type hint. Re-execute. List index out of range is matching folder : 1. Yes, I don't know why I did that. We expect it to be a length 1, but our index should be 0. Okay, so I called this folders down below, but I was calling it deers up above, so that's why we didn't fill in anything. All right, so our directory name / parent none has 2 files, b and c.dat. Let me just move this over here so we can compare. Has b and c.dat. Yep, b.txt.dat. Then it has folders A with a parent is ... Okay. Files is f and g, and h.lst with a folder E with a file I. Looks like we're getting it right. Cool. All right. Looks like we parsed the input. Next thing we got to do is calculate the size. So this is pretty. Now we could do this with like some crazy, not crazy, but we could do this recursively or dynamic programmingly, but we're just gonna make it easy on ourselves and do directory method called def size self return sum of size for size, comma, underscore in files, plus sum of d.size for d in self.folders. We forgot self here. So this just sums the size for everything. And then we should also recursively, we need to get the size of each subfolder as well. And so what we want to do, that's actually probably more important than this size function, actually. We might throw that away. We want to do all folders size, self, and then we want to pass in a prefix here. And the reason we want to do that is because we maybe down in the directory structure and we want to prefix everything. We don't want to reference parents here because that gets into recursion and self-reference, and that can be complex. So we're gonna return a list of tuples into folder sizes. So first we're gonna print our size. So our equals self.size, comma, f colon, so this is prefix slash self.name. So a little string interpolation there. And then sub, so this is our subfolders, equals f for, so entry for entry in folder dot all folders size self, and then our prefix should actually be now pass down into all folder size. But this is actually going to be a two-step list comprehension. So we're going to do for folder in self.folders. Okay, so this will just get us each sub entry, and then we return our size, our prefix plus sub. And that should return all folder size. Nice. So we can even optimize this because technically we're calling like d.size a lot here. So what I'm going to do is optimize this out. We're going to remove this size function. And what we're going to do is calculate our size now. Our size equals sum of size for size, comma, underscore in self.files plus size plus sum of size for size, comma, underscore in sub folders. I'm now renaming sub to subfolders because I think it's a better name. All right, and yeah, technically we could just concatenate those two because they are the same type. Actually, Python wouldn't even care if they're the same type, but I care if they're the same type. So, and now this is nice and clean. So we're summing the size of each file and each subfolder, and we are returning our size and our prefix to all the subfolders. So nice, cool. That should get us all folder size, and then our part one. So we do all equals tree.all folders size, and we just need to calculate a sum for folder in all if folder dot for size comma name size comma name in if the size is less than 100,000, then sum plus equals size. We return the sum. And that should be everything. We are now just going through and looking for each size that's less than 100,000. So 95,437 is what we're looking for. Prefix. The prefix here is empty when we call it the first time. Takes two positional arguments, but three were given. We're calling it with, jeez, oopsie. So when we call it recursively, you don't pass your own self. 95437, correct. So let's do it on the input. That is not the right answer. My right answer is too high. All right, cool. All right, so this is our first time we got it wrong. So let's debug, let's figure out what we did wrong and go from there. Let's make sure we read the problem, right? To begin, find all directories with a total size of at most 100,000, then calculate the sum of their total sizes. So, first thing I want to do is look at our directory, but the directory tree of the is going to be really big, so we're going to write a printing function. Sorry, just making a nice printing function here. We're going to print each file on a different line plus dir.stir f4f in self.folders. and plus, and we're gonna do this, and we're gonna, this should be a new line. Oh, okay, actually we're gonna do space before any, and we're gonna do one space prefixing folders and one space prefixing files, and that will work. Why is this bad? Join. Oh, no, join. Yep. Okay. And now let's print tree. Okay. Let's do this in the example. Look, see how it looks. So slash has a. Nine. So now we're gonna add a space between each new line. This is not, oh gosh, dot split lines. Okay, now we have nice input. So we have, oh gosh, whoops. I apologize. 1 second. All right. My nose runs year round. All right, so we have the right answer for the example, but I just want to take a look at how we're doing this. This looks like the directory structure that we should have. Okay, so now let's look at our calculated output. Print all, and we're gonna print, an extra new line here. Well, we have a lot of slashes, but names don't matter. So oh, wait, at most, exactly 100,000. Wait, never mind. Sorry. Two thoughts. I thought that, okay, we missed this less than or equals, which is important because this is of at most 100,000 and we put less than, so something of 100,000. But then it said that our output was too big. So by adding this, it would only make our output bigger. So that shouldn't work. It shouldn't that won't give us the right answer all of a sudden. So let's go over the input. Oh, there's a lot of directories to count here. Why are we getting so many slashes? Yeah, our top name should be empty, maybe? I'm sorry, I'm just wondering why there's so many slashes. I know it doesn't really cause any problem. All right, now we fixed the naming issue, not a real issue. All right, so we're counting a lot of directories here. Okay, it looks like we're counting this directory even though it's way bigger than 100,000. So there's our bug. Oh, right, we're printing here, even though we need to print here. Okay, so that's a bug just with the print, not with the actual output. All right, so everything we're counting is less than 100,000, of course. And we have our total size of every directory. So this is our entire structure. It's a big structure. So for instance, okay, MNZBNL has size 624 and we're counting it, right? Yeah. And then FBHZ has size 624 and 115. And then it looks like there's the same name of a folder above it that we should see 2 FBHCs. There's a lot of FBHCs actually. It's a repeated thing. Yes, it's very much repeated. So 624 plus the 115 gets us 739. Why is this 1363? Yeah, so I wonder why FBHC here isn't being counted twice. Well, it is, but it's size 1363. Why is that? Because I think it should be 739, right? So let me just do import ipdb.set trace. This is a little Python debugging. Pip install ipdb. Sorry, my Python situation here. All right, we're just, okay. All right. All right, so tree, so which one are we looking at? This tree dot folders, all F and all if. Okay, so this gives us all the folders that are less than 100,000, which is what I want. Actually, you know, I'm just going to rerun this down here so I have everything printed above and it's nice and easy. Okay, rerunning it, debugging. So the question I'm asking myself right now is, what is in VWLPS/FBHC? Tree.folders. This should be F4F in tree.folder. We should just make a get function on this thing. Get self name stir directory. And it return F4F in self.folders if f.name equals name 0, and this will just fail if you get something that isn't there, which is fine. Do tree.get VWLPS. Okay, we'll call that VW, and then we're going to do VW.get FBHC. Okay, FB.all_folders size. Prefix, we're going to just pass it an empty string. Okay, so that's what we get normally. So we do FB.files. It has no files. FB.folders. It has a lot of folders. Why does it have so many folders? FB.folders.len. oh, it only has one, but when you print it, it's all weird, right? So we do sorry, it only has one, so we do index 0. Right, that's what we expect, and we do stir FB. All right, this is all it has in it, and yet it thinks its size is double. So sum size for size in self.files plus subfolders. Subfolders. Oh, because this will double count a bunch of things. Ah, we found the bug. Okay, so what is the issue here? When we print the subfolder, we're say in this case, in this very specific case, scroll back up to here. When this guy gets its own subfolders, it gets FBHC 739 and it gets FBHC MNZ BNL 624. Now it should just take FBHC's subfolder, but it's actually adding it to 624 to that, and which is double counting this and could like triple and quadruple count everything. And so we just did if we had kept that size function that we had earlier, we wouldn't have this problem. But we don't. We still do. So what do we want to do in this case? Do we want to put the size function back, or do we want to parse through these subfolders? So first of all, let's split this out. So we only want to get the sum of size for size name in subfolders if that subfolder is only a single level subfolder. So if name.split on slash and we name after our prefix our to if we only have one slash after our prefix, and this won't actually work for the top level. So the problem is this line is futzes with the prefix thing, so we can't. So this really just doesn't work. So what we're gonna do is just call size separately. We're gonna calculate things double, but it'll be right. Def size self. We're gonna put this size function back, return sum of size for size empty in self.files plus sum of f.size for f in self.folders. And this will double count a bunch of things, but it'll be right. So, in this case, right is better than wrong. Let's make sure we still have the correct answer, 95437, and do run it on the input, 1315285. Is that what we submitted? Well, look here, we're lowering things. So let's go back, submit. We did get the right answer that time. All right, we had a subtle bug in our code, and sometimes that just happens. So let's continue to part 2. Now we're ready to choose a directory to delete. The total disk space available 70 million. To run the update, you need unused space of at least 300, some big number. You need to find a directory that you can delete that will free up enough space to run the update. In the example above, total autonomous directory for it. This means the unused space is currently this, which isn't quite that. So the update still requires, so you find a directory which is this much, and so you would delete D. Choose the smallest. Yeah, okay, so we just choose the smallest one that's above the needed space. So, all right. So we have total disk is this number, and need is need disk is this number, and avail disk or is taken disk is equals tree.size. Then we need to find all of the sizes in our output. Oh, our string output, actually, we can just like leverage our string output, right? I don't know. No, we can just use our all folder size, right? So all folder sizes equals tree to all folders size slash, and we just want to sort. We want to sort this. So folder sizes sort on. We just sort it because the first value is the integer. So now we're sorting the directories by size, and we just need to find the first one that is available. So how much space do we need to delete? Need to delete is need disk. So, available disk equals total disk minus taken disk. And then what we need to delete is need disk minus available disk. So we need to increase our available disk to the needed disk. And so we need to find a number as big as that. So print need to delete. And then we do for size name in folder sizes, if size is greater than or equal to need to delete, print found size name just for some debugging, and return size. Find the smallest directory. What is the total size of that directory? Right, so we just return the size. Okay, so this should be right. We're going to run it on the example, and we get /d, which is what they do in the example. So we'll run it on the input, and we get this 984 number. Do that, and we get a gold star. We did it correctly. We had a subtle bug today. These are going to happen, especially as these problems get harder. But I hope you enjoyed watching me debug. And yeah, I'll see you guys tomorrow. Cheers.